Okay, good morning and welcome to the third day of C3S General Assembly. I hope you had a good evening yesterday. We brought in the special effect for our cocktail and icebreaker, visual and sound, all included. We are now getting to the final day. We start now and we'll continue until lunchtime today, and then we'll have an important session this afternoon with NCPs and Spanish days and other side meetings. I just want to kick off this third day with a keynote. I'm very pleased that our friend and colleague Peter Thorne has accepted to give a speech, a keynote this morning about the rationalization of ECVs. As you know, ECVs have been a pillar of C3S, and the GCOS ECVs are going through a refresher, evolution. And so Peter Thorne, who most of you know very well, but is a professor at Maynooth University, has been lead author and coordinating lead authors on the IPCC and has been leading this rationalization effort within GCOS. So I leave the floor to Peter, and thank you very much for being with us today.
Okay, thank you. I'm glad to see they've got, after the party, a fairly idiot-proof thing. It has two buttons, next and back. I think even I can manage that. I promise not to shout. I hear the party was good, folks, evidenced by the half-empty room. I'm sure it'll be full by the end of the talk, honest. So I'm going to talk about the GCOS ECV rationalization. And I'm doing this principally because we've just opened the public review. I'm the chair of the task team on ECV rationalization. I have to thank both Carlo and Sarah Connors, who are here, who have been members of that group. There are also members from the panels. So I'm going to give a reminder of what the ECV concept and framework is. Most of you know that. Why we think it's needed to rationalize these in the timeline, the scope of the public review, the definitions of governance of the ECV process, typology of changes and examples, the main outcomes, and the public review process and how to participate. So why are ECVs important? Well, they increasingly focus investments on observational infrastructure and research, including major international programs. We've heard multiple times during these 3 days, ECVs as a guiding light for many things that the Copernicus Climate Change Service does. It's also driving much of what ESA does in its CCI program, and many other national and international funding efforts are driven by these essential climate variables. They are used to evaluate the adequacy of the observing system for climate. We use them to establish standards and practices for climate monitoring and climate data management. We use them to mobilize climate observing communities, and they're used in the development and implementation of international climate policy frameworks related to climate, in particular UNFCCC. We currently have 55 essential climate variables. They're over different domains, the atmosphere, the ocean, and the terrestrial. And the criteria to be an essential climate variable is it must be feasible, cost-effective, and relevant, and it must also be essential. Why do we need to now step back and rationalize? If you like, GCOS is in the midst of a midlife crisis. We need to step back and question whether everything that we have defined as an essential climate variable in the last 20 years truly is essential. Are we missing anything? We can't say everything is essential. So we need to think, is what we say is essential really essential? Is the current grouping the best possible? So these have been developed by the panels quasi-independently. Different panels have taken different approaches. Does that make sense? Is it consistent across domains in the Earth cycles? And is there fundamentally enough transparency and coherence here if programs like Copernicus Climate Change Service or ESA are hanging millions and millions of euros off this framework? It's a little bit embarrassing if there is not a rock-solid basis for the program on ECVs. We've been doing this for a while, folks. So we kicked this off 2 years ago. We've gone through a process of design amongst the task team. We then, late last year, went and talked to key selected stakeholders, many of whom are in this room and were consulted. And we're now just in the point where the blue arrow is here, called public review. This is where we need to hear from you, and we really do need to hear from you. We will then take those outcomes, meet again, come up with a final list, produce a paper to make clear what this new process is and what the new ECV list will be. But I must stress the ECV list will not change until the next implementation plan in 2028. So we are slow, we are deliberate, we are inclusive, and we are transparent in how we are moving from the current status to a new status. So we're asking for your buy-in, your input, and we are at this public review part, and that allows climate observations community to influence the final ECV list. We will not do everything everybody tells us. That's impossible, but it is your opportunity to influence it. So, first thing, governance. What are we doing with governance? Well, current is a bit informal, and we're making it more formal. You can read this afterwards. I won't read through the text in the interest of time, but trust me when I tell you we are taking a very informal ad hoc process and we were making it much, much more formal with many more checks and balances in the process and also much more transparent. We're also improving the definitions of ECVs and what we're now going to call ECV quantities, which is the correct terminology because they're the things that are observable. ECV products are the things you produce with things like ERA 5 or a satellite's climate data record. We should not confuse people, so we're changing nomenclature, we're bringing metrological rigor into the definitions. Okay, the interesting part you'll all want to know, what are we actually doing? So these are proposed changes, nothing is final. We are going to remove 2 ECVs. They're the 2 anthropogenic ECVs. That's the proposal on the table. Anthropogenic greenhouse gas emissions, because you can't measure them globally. You cannot measure the emissions from every tailpipe, from every cow, from every sheep, from every rice paddy field. Impossible. You can measure the greenhouse gases, etc. So it's not like we're dropping greenhouse gas measurements. They are clearly highly important, but we do not believe that is relevant. Similarly, anthropogenic water use, we scratched our head and said, well, how's that a climate variable? It's an important variable, an important thing, but it's not climate. There are 19 what we would call new ECVs. They're not really new, guys. They are actually amalgamations of existing ECVs. There is changes in terminology for clarity. There is a lot of grouping. There are a lot of ECVs which was something like atmospheric temperature in the first 1.5 to 2 meters is distinct from the rest of the atmospheric column. That doesn't necessarily make sense. You want to measure the entire atmospheric temperature profile and you want to think about it in an integrated way. We have 4 cross-panel ECVs. So these are things that explicitly cross domains. Methane and short-lived greenhouse gases, CO2 and long-lived greenhouse gases. So this is recognizing that we should be dealing with the shorter-lived forces differently from the long-lived forces, and albedo and turbulent heat fluxes. And we've moved some ECVs around. So I'm going to give an example of something that we've done. So originally in the ocean we had surface currents, subsurface currents, and transient traces. And we scratched our heads and say, they're all really trying to get at ocean circulation, aren't they? So we're proposing to mix those together into a new ECV, ocean circulation. If we're calling something like sea ice or lakes, then ocean circulation is the natural ECV. We're grouping the quantities, we're changing the quantities for meteorological rigor and also so that the things we can actually measure. I have one big open question in the public review, which we have not agreed as a task team. So we have an options. We can either group all the near surface temperatures together and have them as an ECV that's cross-panel. So that means atmospheric temperature, lake surface water temperature, land surface temperature, sea surface temperature, skin and bulk, sea ice surface temperature, arguably land ice surface temperature should also be in here. Or we can distribute them to their ECVs. We can see arguments both ways. We want to hear from the community which works for you, why. So we start with 55 ECVs and 177 misnamed ECV products. We end up with 42 ECVs and 177 ECV quantities, which of course means we know the answer. We've just forgotten what the question was. So what's been achieved? We feel we have simplified, we have greater fairness, we have greater consistency, we have greater transparency, we have clarification of concepts. And now it's your turn. Public review time, folks. We need you to participate in the public review, noting that nothing is final until everything is final. The materials are up on our friends, the IPCC's website. They're available for you to look at. You can do it offline, you can do it online. Consider the ECV and ECV quantities in their entirety, please. Consider the proposal. Pay attention to the prompt questions we've given. Suggestions should be properly justified and referenced. Constructive is better, and you do not need to provide a comment on everything. So you could suggest an ECV or ECV quantity is not necessary, it's missing, different groupings. You could do changes to categorization, or you could make editorial suggestions. Thank you, your input really matters. I'll leave this dwell slide so you can take a photo of it so you've got the URL. That's it, thank you very much.
Thank you, Peter. There is time for questions. Should there be some? Please, Monsieur, over there.
It's just like a comment from the point of view of European policies that we are not using ECVs per se as the performance indicators in our policies, but we are also coming out with a new initiative of European adaptation plan where the indicators will also have to be developed. So just for you to tell, if you leave us the space for a consultation long enough, we can also contribute. How do our indicators, let's say our indicators, develop indicators with the member states of European Union will relate to ECVs? So just a comment.
Okay, thank you. I would note that the public review comment period is till the 8th of September, so we have some finite window here.
Other question or reactions? Oh, thank you. Okay, great. Well, thank you very much. Thank you, Peter. And it's important, I think it's important to remind that this consultation is open, and indeed the value of this rationalization is can only be achieved through the feedback and the comment, constructive comment from the entire community. So please do engage. We remain, for this morning, we remain on ECVs, on observation, and I'm pleased to introduce the second speaker for today, who is Rémi Rocca, and he will be talking about precipitation this time. And Rémi is is a director of the research with the C3S in France and has been working on observation for a long period of his life, and in particular is interested in energy and water cycle. So, Remy, I leave the floor to you.
Thank you very much. So, hello everybody. I'm so sorry not to be live with you in beautiful Valencia, but I hope you will bear with me and that it will not prevent you from enjoying that presentation. And before I get started, I just want to thank the organizer for giving me the opportunity to showcase some work which I've been doing for quite some time now with a bunch of people around me, which you can see the names, and I will further emphasize their contribution as I walk through the slides. So the idea is to show you an effort that arises from the research world, not from the operational world, but that may eventually fit some of the needs of the more general a picture we have on the data in our climate changing world. So we call it frogs. It's a database. So frogs, it's a joke because we are the French people doing Précip. So and my English colleague were joking about the frogs, and so that's where we pick up the name. And we are basically providing a database where we take everything that is available and we put them on the same grid, 1 degree by 1 degree by 1 day. And that way, we simplify the access to the data so that a number of people who may feel it's difficult to reach out to so many new products, from reanalysis to RainGauge-based data set or new version of the latest satellite flagship product from NASA or Europe, is now able to access this data. And I'm going to show you a few of those examples. So, the outline of the presentation is simply walk through the history of the frogs database effort, and I will take some time to show you some very recent example of what we are doing with this data set before I end up with an outlook for the future. So historically, you're probably familiar with all of those acronyms, but in case you're not, all of this effort was triggered by GEWEX. So GEWEX stands for Global Energy and Water Exchange, and it's a core project of the W3RP, so the World Climate Research Program, which is hosted by WMO and UNESCO and other sponsors. And so this is a research program, as you could hear, and in this case, there was a strong impetus for various scientists in this environment to try to address some of the challenges around the extreme precipitation and other climate extreme. And so for that purpose, we gather all together in Germany, in Offenbach at DVD under the auspice of the CMSAF. You can recognize some of the faces on the picture. Some of them are probably in the room together with you. And so we had this original meeting that was mainly a hands-on meeting where we shared the data files in a very informal way, and it triggers so much interest that we ended up having a special issue in a journal that allowed us to have a first bunch of 20 papers or so that was addressing some of the current limitation of our understanding of the extreme evolution over the last decades. And it was the opportunity for us to provide the reference paper for this data set, and we address all the FIR aspect of the data distribution through the release of a DOI and all of that. So in parallel of this very sciencey aspect, we were also involved, and this dataset was more or less designed to support precipitation assessment effort that I led as I was the chair of the IPWG, International Precipitation Working Group, from WMO and CGMS, if some of you are familiar with those bodies, and jointly run with WCRP, where we were able to really give a state of the art of what is the global picture on Precip. So that was the initial impetus. So the database is alive, and it has now more than 50 datasets. I will show you a couple of examples in a second. So as I said already, it is composed of ground-based satellite and reanalysis input. It can be global or regional. It's always on the same format, same resolution. It's a common NetCDF format that respects most of the recent norms in the climate world, so that it's easy to use and sustain over all the products. And thanks to the effort of IRIS and IPSL, since a couple of years, this very research-led effort initially is now supported in a sustained way, where we have Sophie and Jeremy working at IPSL that are updating the database on a best effort basis yet. But every year we update until the last months of the previous year all the datasets that have been progressing so far. And when there is a new dataset, upon request from the user or from ourselves, we just add it as it is released. For instance, for RFI, when it came along, we were able to download it and to reformat before we were able to input it in the Frogs database. So this is the URL where you can click and see all of the data set. This is an example of it. So I'm not going to go into detail. Probably you can't read in that slide. Maybe the slide has not changed yet. Is it changing? Yes. Yeah, you can't read much. It's all the products that are here listed by whether they are global, satellite, or reanalysis, or local, etc. But before I'm going to show you some more data, I want to make one step aside and share with you the result of a survey we just conducted last 2 weeks ago, where we basically analyzed all the 100 almost papers that were using the data. So it's very paper-oriented. And the metrics here is the published paper in the literature, in the scientific literature, that we analyze in detail to see what the people were doing with those data sets. And so I'm not going to go into detail, but the take-home message here is that most of the people are interested about the global land features. Only a very few people are looking over tropical ocean, and it's basically my team doing research on the extreme of the tropical ocean. Everybody else is focusing more or less on the land. And it seems that as far as we are concerned so far, most of the people are working on the extreme. It's really the big topic in the PRECIP world, and this is where all the datasets have been used to explore various aspects of the extreme, being a very moist extreme or very dry extreme. The both ends of the spectrum of the PRECIP are of concern for this community. So it gives us some elements of what people are doing with the data. And now I'm going just to show you some more concrete outcome of this kind of stuff. So first of all, following the discussion we had with Joaquin, we start to build this very first effort to do a multi-source climatology of precipitation. So on the left, you see the global land map of annual daily mean precipitation. So that's in millimeter per day in the annual mean for 2022. And this is an ensemble mean of all the products that are listed above. So we included two different data sets based on rain gauge measurements. We included 6 latest versions of the satellite products that are very well known, like the NASA one, the CMSAF one, the JAXA, the NOAA, and some from the University of Maryland for GPCP and for UC Irvine from Persian. And of course, we also added 2 reanalyses, ERA5 obviously, and the latest release of the Japanese reanalysis. So this gives you a broad feature of the ensemble mean, like if we were using multi-model output in an attempt to get the robust feature out of the data sets. And once you reach this point of doing the ensemble mean, it's obvious you can easily do the standard deviation of the ensemble, which is shown on the right. Here, it has been normalized. And so it gives you an idea of the spread among the products that I listed above, that you can see can reach up to 100% spread. But that's obvious over the very dry area, where a small amount is compared to the mean can be very significant. And more in most of the region where it's raining significantly, we see that the uncertainty reach something like 20% very quickly. And as you can see, and if you were to spend more time on this plot, you will see that as you go on the mountainous area, then the uncertainty is, or the spread, at least among the product, increases very much to reach some value up to 60% easily. So this gives you a feel about where we stand in terms of climatology of precip when you use a large ensemble of products. And so now I'm going just to show you two examples dedicated more to the extreme rather than to the climatology, so that you can see the added value of using a large ensemble. So it's a study that I've been doing for a few years, thanks to the support of the UMETSAT CMSAF and the Giraffe group, which I am involved in for since almost a decade now, and for which we were able to look at those daily precipitation on the grid. And as I quickly presented on the right, we were using the scaling formula that relates the change in relative change in extreme precipitation, delta PE divided by PE, that should be theoretically scaling with the Clausius-Clapeyron law and the surface temperature at a rate of 6 to 7% per Kelvin warming. So in order to analyze the precip under this very specific framework, we computed some percentile of the distribution after we have been using the SST field to or the surface temperature from RR5 to actually look at the scaling, and you have an example of the result below. So on the left, the plot shows the scaling over land, and you see that there is a lot of small spread among the various products, and all the products do have the proper slope, which is 6.57% per Kelvin, sorry. So we have a very consistent picture over tropical, it's tropical, yes, tropical land. If you look over tropical ocean, on the other hand, you still find a lot of the product who has a physical trend, that is a very physically sound scaling of the precipitation with SST over the 300 to 302 Kelvin range. But you see a large spread among the product, which is going almost by a factor of more than 2 in the magnitude of the extreme over the ocean. So in order to explore if this situation a few years back was still up to date, we have made an effort recently to rerun some of our diagnostic on the latest generation of the product, and we were able to write a little summary of this finding into the GeoX quarterly newsletter. So if you want more detail, you're welcome to download this. It's easily accessible on the web. And so on the left here, you see the previous generation, the plot I've just shown you over the ocean and the scaling. And here you see on the right the new generation. So if you omit this reddish product that is an outlier from the core of the product, we see that from a factor of 2, we are now down to a factor of 30% of spread among the product. And we still see this very genuine behavior of the product that are showing a very physically sound scaling. So we are still keeping the good news of the previous generation, that there is some physics in the product that is associated with the scaling of the SST and the extreme precip, and the spread among the products seems to go down. So this is a strong incentive for our colleague from GeoX to actually rerun a more up-to-date assessment, and I hope in the future we'll hear about it and to showcase the effort of the data producer who are working hard to improve the products. So that was one example, and before I end, I'm going just to show you this one figure. It's a work done by Lisa Alexander, who is a professor in Australia, and who's been taking all of the data set in frogs. So Lisa was involved since day one in the frogs product, and she's been looking at the extreme for a long time now, and she has been trying to assess whether there will be some differences between the regional product versus the global product. So it happens so that in this precip world, you have a lot of rain-based gauge regional climatology that are enhanced compared to what you can do at the global scale. And so there are some various climatology that do not have the same input data, whether it's led by a regional center over Southeast Asia, for instance, or whether it's run by the GPCC center in Germany that is having a more global picture. And surprisingly enough, there is this very strong signal coming out. This is the map is showing you the number of data sets that are global data sets that are showing extreme much wetter than the regional dataset. So over most of the global land, except over Australia and South America, we clearly have a systematic difference in the appreciation of the magnitude of the extreme. So this is a very new result. It's still under review, and it calls for a much more in-depth assessment of the differences between the global, regional, and how the algorithms are performing to produce at the end so much different extreme. Okay, so that's typically the kind of study that we are running through at this stage. And so if I try to wrap up my presentation now, I can tell you that the status of the database is up and running. You could see that. There's a lot of focus on global land and moist extreme, not so much on drought though, but a few people are using those data to do some science of the drought. And there is a very exciting paper last fall in Nature showing how the observational constraint from the ensemble of data, precipitation data, can showcase that most of the CMF6 model were actually overestimating the increase in the length of the dry spell in the future. So that's very, very active in the research world to use this ensemble of data to try to put more constraint on some model projection. That's a big event. As you could see very transparently, as we just heard before in the previous presentation, this is not, we don't have the final word on PRECIP. There's a lot of discussion on why the estimates are varying so widely in some cases, or why they do converge as well in some cases. We could see that some of the data sets are actually very physically sound, although they differ by almost a factor of 2 in some of the magnitude of the most extreme PRECIP. So this is something that the research and the data provider community is trying to address, and but it's still a ongoing work. We don't have the final word on this topic, and that's why I think using an ensemble of dataset rather than a single is preventing the user to make a statement that could be actually too much product dependent in the analysis or in the climate service that you are running. We are looking towards adding more dataset to the database actually. Especially, we are very short on the strong effort around the regional reanalysis, and probably we will work closer with Joaquin and our group at IPSL to access the most recent regional reanalysis, so that it can really enhance the added value of the ensemble approach over some of the key regions of interest to the users. As far as the operation are concerned, the database is sustained thanks to IRIS and IPSL, but again, it's a best effort. And so we are having an ongoing discussion with C3S to think of how we could have a CDS-based distribution of the dataset and maybe enhance a bit the production on our side. So with this, I'm finished, and I'm be happy to take some of your questions.
Thank you very much, Remy, for this very interesting presentation. Questions? I do have one myself. Actually, it emerged the other day. In the plot you've shown about the Clausius-Clapeyron relationship for precipitation, yes, there's this good fit between 301 and 303, yes, roughly, Kelvin. Yes, yes. What happened outside that boundary? So why is the fit only within that range?
So on the right side, on the warm side, you hit a regime of very warm SST or very warm surface temperature that is deprived of precip, because you are becoming so arid to reach this temperature that you don't have precip anymore, because you are in a moisture limited regime. There is no more moisture if you get so dry. Or over the ocean, it's suppressed condition that allow the SST to warm up to above 303 Kelvin. And so if there is no more intense precip, you could see it more on the land. The limitation is due to the relative humidity. As far as the cold regime is concerned, it's not clear yet why we don't see no sensitivity in the colder regime with the extreme. What we know is that only a very small fraction of the precip is actually falling into this this regime. This cold regime is like less than 5% of the total precip is falling on the cold regime, but it's still a region where you can see some very, very different behavior amongst the product. For instance, over the ocean, you see that the pink product is actually showing a decrease between 298 and 300, while all the other are more or less showing an increase. So this is a region of even less agreement amongst the product, which is probably something that also need to be understood in more detail.
Thank you very much. That was very, very useful explanation. Any other questions? Okay. Thank you very much, Remy.
Thank you for the invitation.
So this morning we started from observation, and now we have a bit of a shift in gears, because we move from observation into modeling, and in particular into projection. So I leave the floor to Anke Brukshaw, who will introduce the panel and lead the discussion on this topic.
Thank you. I've got a microphone. Oh yes, I should probably invite them over. The panel today is going to be made up of three people. Our colleague Tim Stockdale, who is in Reading and will join us online. Irina Sandu, the director of the Destination Earth activity at ECMWF, and Francisco Doblas Reyes from Barcelona Supercomputing Center. We do have screens to watch Tim's presentation here, so we are not going to miss out. I think we should be ready to intervene and to interact. I would like participation from the audience today. We want to set out some guidelines and some principles, and then invite you to take part in the conversation actively. The whole topic is supposed to focus on what we think of as operationalization of climate projections. We've heard this mentioned before in C3S General Assemblies last year. There were some topics on this. The idea today is to try and dig a bit deeper. We are not going to exhaust the possibility. Even discussing what operational might mean in this context could take us an hour or longer. The idea is to just try to look at some points. We can think of operationalization as creating services for users on an operational schedule, and therefore it's a matter for climate services to resolve. We can think of it as being a operational status access to data, and therefore it's a matter for, again, some types of services to address. Or we can think of it as something that is more akin to predictions, which means updating the model simulations on a regular basis to take into account the latest developments in the climate system and in technology, and that it becomes a matter for modeling centers potentially. So today I propose we structure the whole discussion along the following lines. We need to think about inputs. If we were to do predictions or projections more frequently and more appropriately and accurately, we would need to think about the inputs to the models, the inputs to these simulations. We then need to think about the technology that needs to be employed, and we need to think about the infrastructure that needs to serve all this. I just want to remind you before we start that CMIP, which is the source of all or most of our information from climate projections, was never intended as a exercise in sampling uncertainties to serve users and to inform decisions in a complete way. It was a model intercomparison project. It was a research project. It was an exercise in trying to understand how the models respond to the forcings in the climate system. We have ended up in a position where we have to use that as the main resource to help us make decisions that affect a variety of sectors in the future. Now, we want to start with a discussion about inputs, and in particular, the part of inputs we want to discuss is the forcings, the external boundary conditions that that the predictions or projections on various timescales, even the reanalysis, need. Tim Stockdale has been in great demand in the last few months with the changes to the operational system for seasonal forecasting at ECMWF, as well as with the setup of the reanalysis, the new reanalysis, in trying to get a handle on how we treat the very heterogeneous data that we have that provides us the forcings for our simulations, for our model simulations. So I'm going to invite Tim to tell us about what the state of the art is and what the reality of a practical approach involved in operation is.
Okay, thank you. So first question is, can my slides go up on the screen? Are they visible?
We can't hear him very well.
Sorry, can you not hear me very well?
We can see, but we can't hear.
Maybe it's here. It's okay. Then it's okay.
I told you we should stay there.
Can you hear me now?
Thank you. Or we can just ignore Tim. If we don't hear him, we can't take notice. Thank you, Tim. Your turn.
Can you hear me at all or not?
Yes, we can.
Good. Okay. So, Hank has given me an introduction. I'm going to talk about forcings. Some of these slides were from a meeting last October with the CMIP community, thinking CMIP 7, but also where we were looking forward to the possibilities of producing forcings on a more regularly updated basis. So, as Hank has mentioned, if we're going to do frequently updated climate projections, so that's the producing them aspect of the operational that Anka mentioned, we clearly need infrastructure to run the projections. So we need model, we need compute resources, we need the software environment. And we also need some sort of initial conditions. One reason for updating a projection is that the starting point might have changed. So, the way the climate system has evolved over the last couple of years means that our expectations have changed because the starting point has changed. But I imagine we may come to some of those things later in the round table. But what I want to show here is just a few slides on the specification of the climate forcings. And I just want to mention that we need these forcings not just for climate projections and updating climate projections, but it's also relevant when we come to reanalyses, because reanalyses need to know what the climate forcings are, and also for seasonal prediction. So it's worth considering when we're thinking of requirements for those three different needs, the requirements for three different needs to consider them together. Reanalysis, we would like high quality and consistent climate forcings. To some extent, it's less critical in reanalysis because, of course, we have all the data that we're analyzing that constrain the system. So something like mid-tropospheric temperature is quite well constrained by all of the temperature data that we have. This is just a time series of the increments being made in the ERA 5 system from the 1940s up to the 2020s. The model that we're assimilating data into has biases, so we expect that the mean increments will not necessarily be zero, but we would like those biases to be constant in time if we've got the forcing right. And you can see that the increments are not completely constant in time. Some of this is changing observing systems, but it sort of makes the point that particularly in areas like the upper stratosphere where the data may not constrain things completely, there can be some knock-through effect if we get the forcings wrong. So we would like to have good quality climate forcing. Also, there's technical issues on how we do variational bias correction of most data sets that mean that the model first guess actually has quite a lot of influence. And the other thing that reanalysis likes is traceability and credibility. So when we've been considering the forcings for ERA 6, we don't want to go off and make up our own sort of ad hoc forcings. We want to follow community standards, use best practice, so that it's easy to document and trace exactly what's been done. Now, when we get onto seasonal forecasting, these climate forcings actually become a bit more important. A couple of points here, really. The first point is a very simple one, that the climate change signal has become a key part of the seasonal forecast, almost the key part of the seasonal forecast. It used to be, 20 plus years ago when we started seasonal prediction 30 years ago, ENSO was the biggest driver, and that's still true of the year-to-year changes, are dominated by ENSO in the tropics and other tropical forcings. But actually, if we're talking about what to expect for this coming summer, climate change is the biggest driver of that compared to the last 20 or 30 years. And therefore, getting that climate change signal correct in a seasonal forecast is really important. We calibrate the real-time forecasts against reforecasts that are made over the last something like 30 years. To do that successfully, we need that the biases in the model are basically consistent over time, and that means we need the climate forcings to be correctly represented. And actually, some of the uncertainties in the climate forcings and the uncertainties in the changes over those are significant drivers of uncertainty in the seasonal forecast. So all the issues around aerosols and cloud feedbacks and so on, and there've been rapid, substantial changes in aerosols in recent years that may or may not be responsible for some of the quite rapid changes in global warming that we've seen. And I just mentioned that this is challenging in a seasonal forecast system because these are really real-time systems, and most data sets that are available are either near real-time data sets. There's a lot of people working on near real-time data, but they don't have necessarily go back very far in time. They're not very focused on what happened 10, 20 years ago. Or we get data sets which scientists produce essentially as a sort of careful reanalysis of past data, but typically, stop like 2 years ago. So you can either have sort of climate quality, reference quality data that's for the past, but not in real time, or you can have near real time data that doesn't have high climate quality in the past. And having data sets that provide both of those is not always easy to find. So that's just a bit of background. And then, of course, the other requirement is if we want to do update a climate projection, similarly, we want to update the forcing. As Anka mentioned, we've traditionally used sort of CMIP forcing. So CMIP 6 is the latest forcing that is fully available. There's CMIP 7 sort of prototype forcings becoming available. CMIP 6 forcing data sets basically finish at the end of 2014 in most cases. So that gives you an idea of how far out of date these forcings can become. And even for something like the solar cycle, you get a sort of 10 years out of date, 6 years out of date, and your estimates can be quite a long way off. So what CMIP 6 did, they had reconstructions of total solar irradiance in the past. That's the bluer line on this plot up to 2015, and then estimates going forward. And of course, predicting the solar cycle is a challenge, both the phase of it and in particular the magnitude. You can see from this that there's a periodicity between solar max and solar min, but there's also a question of the amplitude in particular of solar max. And solar physicists don't always agree on that. There's a lot of discussion on the present solar cycle, which is this one here, which has turned out to be quite strong. This is the green line. A lot of groups were predicting this would be a very weak signal. After the previous weak one, there was a view that, certainly in CMIP 6, there was a view that the sort of mid-20th century was a peak of solar activity, and that going into the 21st century, these are the blue lines here, we'd have a low level of solar activity. And that is now rather changed. Partly the past data has been revised, and this is now fixed for CMIP7, and the future is uncertain. So this is one particular projection that we're using, but this is absolutely subject to revision, and we just don't know. But the point is, if you're using solar forcing data from several years ago, you really might miss what's happening. We did experiments here at ECNWF using the latest observed total solar irradiance estimates in 23 and 24, and they contribute measurably to the strength of global mean temperatures that we've seen. And a lot of the CMIP models, well, all of the CMIP6 models were using a lower level of solar forcing. Solar forcing is interesting because the CMIP7 main data set is based on actually a new climate data record that's been produced in the US. And that actually is an operational product that's available each day. But for CMIP purposes, of course, you need to know the future. So they haven't officially released the future estimates yet for CMIP7. We're using the ones from the same people who produce the observed data. And that is, anyway, that's a little bit about the solar forcing, that we need to worry about what that's going to be. Tropospheric aerosols are a big driver of affecting the heat balance of the Earth, both globally and also regionally. And of course, aerosols change over time. For ERA6 and for C6, we've generated a time-varying climatology. And we've done that by taking the chemistry model that we have from CAMS and driven it with specified emissions. And we've done this for the past, so up to roughly present, using the latest sort of community estimates of emissions. So this is sort of post-CMIP6. And we've been able to do that and get an estimate of that, but we've not been able to project that into the future with this particular system, and nor have we been able to keep it up to date. If we're thinking of forcing for climate projections, it's really worth bearing in mind that these emissions estimates, the solar stuff, it's really the observations you just add on each day and you get new observations. These emissions are sort of ground up emissions, and they're really subject to revision. So particularly over China, in CMIP6, they had sort of estimates of what had been happening, but those were subsequently revised and revised downwards quite a lot because the Chinese introduced a lot of emissions controls on the pollution. So these emissions of sort of pollution emissions for aerosols, it's not just the new data that comes in, but the data for the last few years might get revised quite a lot. And therefore, if we're updating climate projection, we might need to start not just sort of at the beginning of this year, we might need to go back several years to sort of do the spin up of that. Volcanic aerosols, we don't talk a lot about actually, partly because we had two big eruptions in the last 50 years now, sort of El Shishan here and Pinatubo. This is a time series from 1979 to a couple of years ago in the tropics, and its extinction as a function of height. So you see these two big eruptions, and then the decay, and then you see some smaller eruptions in the early 2000s and more recent years. The top is the best data set we have, GLOSSAC 2.2, which is based on satellite extinction data, multi-instrument product. The bottom is a modeled version where we have actually a rather simple model called EVAH, but we drive it with specified eruptions. So we have a database of all the volcanic eruptions, and then we try and model that, and do we reproduce these observations? And the answer is, to some extent, not brilliantly actually, even in recent years. And for the real-time forecast systems, we can't obviously know about eruptions that haven't happened yet. The question more is, can we account for all the eruptions that have happened most recently? This GLOSSAC 2.2 is not a real-time data set. It might be updated every couple of years or every year at best. There is a list of volcanic eruptions that of course can be updated in closer to real time if there's a big eruption. But that is at the moment not really done as an operational product. This is just done in research mode, and again not quite kept up to date. There's an email list basically is the best we have for an operational thing, and the decadal people have of course also done some tests of how we'd respond to a volcanic eruption, but it's relevant for both seasonal and decadal. Ozone is an important climate forcer. Some climate models might have full chemistry models, in which case you have to worry about emissions. Others need to specify values. CMIP ozone can come quite late in the CMIP cycle due to how it's generated, and it is just a model estimate. Or you can use linear chemistry models such as we use, in which case you need time varying coefficients to capture the climate trends. It's worth mentioning there are some slight mysteries about tropopause temperature trends in the tropics that are perhaps not fully understood. And there are some question marks, even our state-of-the-art ozone modeling, how good is that? So with all of these issues of specifying forcing data sets, there are sort of practical operational type questions of how we do it. There are also still some scientific uncertainties in many cases. There are other types of things that can change and that are important for the climate, at least locally, in terms of lakes, vegetation changes, land use changes. ERA 6 considers these fixed, but there are developments going on. There's a project funded C3S to prepare for future Copernicus stuff in terms of land forcing. So ERA 6 land will make use of some of these developments. Again, scientifically, it's really quite hard to get consistent time-varying vegetation data sets, even in the satellite era and even in the past, never mind the future. So to some extent, some of these time-varying vegetation land use for projections, whether that's quite ready for operational updates yet, I don't know, or is it still a research question? As was mentioned, there was this meeting last October to talk about the prospects, the paradigms for extending CMIP forcing to allow regular updates. This is sort of my summary of the outcome. If we're thinking about sort of maybe making annual increments to the data, about a year behind, together with updates of how the forcings are expected to evolve in the near future, meaning the next certainly decade or two, the CMIP forcings community really think this is feasible. So this was good news, and they think that the new methods they have, usually there's a problem, or historically there's been a problem, that one group of scientists have looked at the past data and a different set of scientists have produced estimates for the future, and of course they've not matched up at all, and so there's been a lot of effort needed to sort of try and get some sort of continuous estimate, say, of aerosols. But the methods for doing that sort of matching have improved, and they're more automated now. So the CMIP community seem to think that they could do this, that if they were given resources, that this would be a feasible thing, and to produce consistent sort of the recent past and recent future estimates of the forcings on a sort of maybe an annual update basis. So obviously greenhouse gas concentrations are easy, the long-lived ones. The emissions are the big ones that need the sort of meshing. There are some things, this is my personal view on this, that actually there's some things that we really could have maybe almost daily at near real-time updates, which might be particularly interested, say, for the seasonal community or reanalysis community. Biomass burning emissions, because industrial emissions change slowly over time. Forest fires obviously change a lot over time, they're very big, and similarly volcanic emissions can change very quickly. And the solar data is just measured on a daily basis. So some could be updated very frequently. There was no real consensus for that at this meeting, I must say. But anyway, those are the slides I have, so I will stop there so that we can discuss.
Thank you, Tim. Unless there is something really burning, I would like to also touch upon the other elements before we open the conversation more widely. So I invite Irina and Paco back on the stage. Apologies for the logistics. It's entirely my fault, not considering we were an obstacle in the way of the slides. So maybe now, maybe now we can talk about the models and the modeling infrastructure that would be required for this. And Destination Earth is probably the place to start. So I invite Irina to.
Okay, maybe I start and then I hand over to Paco, but it's very nice how you frame, because if we want to operationalize projections collectively, we need to operationalize the inputs, and that's Tim gave a nice overview of the forcings, the historical forcings, but it's also the forcings of the future, and that's something which I don't know how much we can touch upon today. And then there is kind of the backbone, which is not only producing these simulations more regularly, but producing them with methods which are operational, learning from what we have been doing over the past 30 years, for 50 years in numerical weather prediction. And that implies, and often people, when they think about Destination Earth, think about higher resolution, but that's not what the climate digital twin that the CSC, together with BSC and other partners, are implementing is really about applying the methods from numerical weather prediction to climate projections to derive an end-to-end workflow which produces climate projections both more regularly but also in a more flexible manner, and it's end-to-end. It goes from the inputs to certain applications and aims to embed those applications in the workflow. And this entails work in terms of the software infrastructure to run the models. It entails versioning, quality control, a whole framework for real-time evaluation of the climate projections. And then it entails indeed embedding, selecting applications to bring the users along. Because if we change the paradigm and we give users simulations more frequently, well, they need to know how to deal with that. And that's one of the things we are also trying to do. So that would be a kind of overview of what the climate digital twin is aiming for, constructing this more flexible and operational framework to produce climate projections. That requires inputs for us forcings and future scenarios. So it's not the whole story, but it's a part of it. And that's where the efforts in Destination Earth, C3S, but also in the CIMIT community are coming together. And I think we have to learn how to bring these different efforts together to operationalize, to go towards the operationalization of climate projections.
Irina has said something really useful I don't want you to forget whilst we move on briefly to something else, which is the user angle. Users are going to be faced with a completely different rate at which new information about the future comes at them. And I think we haven't begun to think about how users might want to deal with this. But before that, I wanted to just ask whether the infrastructure is ready for it, for this kind of a future in which climate projections are produced more regularly and lots of data is produced, high resolution, large ensembles, and the like.
It depends on how much you include into the infrastructure, and it depends on who pays for the infrastructure. So I would like to, as I told you this morning, more and more I think it's important to talk about the business model of anything that we are doing. The farther away we go from research, and the climate is not research, is something different, the more we have to talk about the business model. And the business model includes governance and funding and decision-making and everything. Let me go one step backwards. The business model of the sources of climate projections right now is not clear. It's very weak. It's at the point of failing at any time. And it's very risky. It's a very risky way of working. And I say this from the perspective of the users, mainly decision makers, policy makers. So it's very difficult to rely on sources of climate projections that are funded mainly from research funding. Not everywhere, but in most cases is funded by research funding, done by, in many cases, postdocs and PhD students. All my respects to postdocs and PhD students. Yes, same thing as the forcings. And somehow huge decisions seem to be taken on the basis of what these poor people are supposed to provide. So it's important to know where we come from. And we come from a framework that is not fit for purpose. And we talk a lot about fit for purpose. It's not fit for purpose at all. So is Destination Earth the solution? I don't know. So it's not for me to say, but it's an attempt to look at this problem from a different perspective. It will work or not, we'll see. And then obviously you need to also put the infrastructure in this discussion. So CMIP and Cortex are painfully looking for computing time to do their simulations. Cortex is suffering even more than CMIP because they are coming down afterwards, and it's an absolute nightmare for many of these institutions that are trying to do these kind of things. Not just a computing time, where to put the data, how to handle the data, what will happen with the SGF, let's see, yeah, geopolitics also are being thrown at the table. The point is that the infrastructure is there. In Europe, we are privileged in many respects in terms of the computing infrastructure. But if it has to come from research, we can only expect what research is able to do. The machines will be there, a lot of support will be there, but the people who will have to run it might suffer a lot from dealing with it.
So, as you know, the current and previous phase of C3S have tried to support the infrastructure and the technology angle with adapting or trying to improve the functionality of the SGF that serves the purposes of C3S. But we haven't come anywhere near close to a solution, and we don't have the resources to do so in the future. So I think it's important to try and prioritize the important things, the key things, and the steps forward. Because the current infrastructure and framework is not fit for purpose, patching things as they are may actually be counterproductive at the moment. So I think we need to think about, just like Tim was explaining, in a forcings world, people want to continue what's happening at the moment at the same time as in parallel building a new paradigm. I think we need to think about that as well.
Can I add something?
Absolutely.
And I think we need to add as well how we combine these different sources of information in a way or another, because we can't just throw continuously new things to users. We have to see where the complementarities are, because there are complementarities between what is done in CMIP, in Cortex, in Destination S, and we have to find ways as well to help users make sense of all this, combine them in a way, both from the science point of view, where the complementarities are, and from the technical point of view. And we had been quite some discussions in the community of how do you actually do that, and what are the platforms, and how do you bring the Euro HPC world together with the ESGF world and the different formats, etc. So that we need to think about as well.
I think there's a lot of, let's call it research, to be done in trying to understand how to combine these things. And the purpose of the services so far has not been to do research. So I think where that activity sits is not even clear. And with the proliferation of the sources of information, again, that is going to be it should be a growth area, but I wonder if that is in fact resourced properly and planned properly ahead. Perspectives from the room? Mark Payne.
Hello, there we go. Mark Payne from the Danish Meteorological Institute. I was really pleased that you brought up the user perspective, because to me that's actually a really interesting part of this question. In Denmark, there's a requirement for all municipalities to have adaptation plans that are no more than 5 years old. But the municipalities really are struggling with the amount of information that's out there at the moment. One extremely large municipality, who shall remain unnamed, is still doing its adaptation based on S3S scenarios from 2010 and 11. So my question is, how much, I agree that this makes sense from the scientific and from our point of view, but how much work has actually been done from the user perspective to actually say, is there a demand from this from the users?
Sorry, Mark, can you repeat the question?
So the question is, how much demand is there coming from the users? This makes sense for us, and it's good practice, and I absolutely support it, but is it only something that's sitting in the scientific community, or is there actually a demand coming in from the outside as well? And how much work has been done to actually quantify that aspect?
I see Carol really on the verge of jumping out of the chair, but as you know very well, the users is a very heterogeneous set of actors. If the users are municipalities, their ability to know what is available and what it means is very different compared to DG Klima, which is another user. And the questions and the requirements are very, very different. So it's a very complex question, and as you know, I quite like these kind of framework questions about climate services. But somehow, the case that you're formulating is pointing at the need of something that we've been already talking about in the last few years, which is the need for reference data sets for projections that don't exist. We don't have reference data sets that in observations they exist. Peter surely can mention plenty of reference data sets for each one of the ECVs or for many ECVs. We don't have the same thing for climate projections. So people are, even now, they hesitate to whether to use CMIP 5 or CMIP 6 because of the warm model issue in CMIP 6, and there are questions about this, very valid questions about this, and it's because we haven't really addressed what the reference data set for projections is, and how to merge it with the other sources, which is, again, much more complicated. But there is not an easy answer because the huge variety of users that we are confronted with. But the demand is there, probably not from the municipalities, but from the intermediaries that are providing and developing the products for those municipalities. Yourselves, the MI, but many private actors as well that are emerging.
I think we'll let Carlo ask his question or provide the answer.
No answer. Questions. Because in a sense, I felt that the three panelists provided three angles to the story. You know, the complexity of having up-to-date forcing that is needed by the projection, the need of changing the infrastructure to do this sustained mode of operation that we never had in climate projections, and then the interface with the users. And none of the three is currently operational, or wasn't, or is in the process of getting there. And now is the impossible question for you, but in a sense, of the three, where do you think is the biggest gap? So where is the element of the ecosystem that is at the moment farther behind where we should be?
I think the link with the users, because on the others we are making progress. I mean, there has been the historical forcing workshop. People are wrapping their heads around how to do this. The climate DT is setting at least the pathway and an example what operationalization mean and how do you define model versioning and frameworks for evaluating the models and embedding, selecting applications, getting the applications to work with data which comes more frequently, but is done with very few. Now, how do you do the uptake and how you ensure the uptake and how do you combine these different sources of information? This has been done very little, but maybe Paco will contradict me.
I had a thing to add there, so I agree, and not maybe even for a different reason, because there's already too much information out there. People have to deal with that today, not when all these things come online so it is an urgent thing and a thing that has been lacking for a long time. But having listened to Tim once again and having been at the workshop raised questions. The workshop raised shortcomings. He came up with very few answers, and the answers that did offer did rely on research funding, did rely on very perishable solutions and single points of failure. So I think it is a serious matter that needs to be addressed quickly if we need to update our projections to take into account the current understanding of you saw the difference in the solar cycle. I did not see the quantification until I saw that plot today. So it's to me that is scary, and that really requires. It's probably not going to be that costly and that complicated, but it needs to be taken seriously, I think, in order to underpin what we do from here on a more robust basis. But I do agree that the user angle has long been wanting some concerted effort to try and standardize things. Sorry, Paco, you go.
Well, I'm not going to agree, just to make it a bit interesting. To me, all three are very important, but there is an elephant in the room, and I go back to the importance of the business model. So we need, and I think that we need to look at this, abstracting ourselves from our research background, which is probably common to many of us here, and think of what we are marketing here, what is our product, and what is the business model for that product. And then everything else should fall into place, because otherwise what we're talking about here is what the French call usine à gaz. So basically a factory with pipes all over the place, yeah? And unless you're a very good chemical engineer, this is very difficult to manage, in particular when there are different owners in the factory. So in my opinion, until we start talking about business models and we present those business models to the Commission and say, this is what we mean, it will be very difficult to make progress.
May I interrupt? Hello?
Absolutely, in a moment.
So
I just wanted to remind Tim that he is also entitled to put the point of view forward, so you make yourself known. But surely we'll go there first.
Yeah, thank you. So I'm the delegate for the Copernicus Committee from Finland, so I can also put that hat on and just tell in a way, I think it's from a C3S point of view, it is not difficult to see that for the seasonal forecast part, I think we have a go. And I would just stress from that point of view that it is very adamant to improve that system, and let's face it, that four things work probably will help then also the other activities. So at least that is something to concentrate on. I would even kind of add some insights from my colleagues from the IS4 Fires, let's say smoke plume 5-day forecasting system that they have with machine learning, even made a wildfire predictor, which works pretty well, because it's like wildfires are humans mostly, or then in some cases in nature lightning, so it's not that difficult actually to get quite okay in the surroundings when you have a not too big resolution model that you can even forecast quite well where a wildfire will be. And then that kind of systems, I think, suggests that at least for the wildfire cases, that's something that you should go after to be more near real time and get that going and done. And there's also, I think, an okay from a point of view that the Copernicus program is wanting that, so kind of improving that system is clear. Climate predictions from this point of view of the Copernicus program has from the start always been the issue that no, we don't want to go to pay for that climate prediction modeling. So unfortunately, from a political point of view, this has the struggle of getting all the member states to agree that this is now something that the Copernicus program would do. So it's a bigger question than what we think is good and what is needed most. It's actually also that the funding behind the Copernicus program has to say yes to it. And I think that's not a given, especially when there's so much pressure for all kinds of other spending. I think to increase that part here is not going to be easy. The next multi-annual financial framework will need so much more for the space component when we have much more satellites flying that I don't think that it's easy to argue. We will, but the question is that it's not that easy. So in that sense, concentrate on the things that at least are necessary, and that's in the seasonal forecast part. Thank you.
I mean, I just wanted a clarification. What Tim was talking about is not a seasonal forecast problem. As he said, we do deal with that quite easily and quite straightforwardly in a practical fashion. This is a feedback, a mechanism to provide feedback on the CIMIC forcings, because what he meant by we wanted to be trusted is he wanted to harmonize the two activities in this perspective. But yes, but I think my recollection from user forum feedback is that interest from the audience exists in the predictions and projections. Yes, the space segment is important to measure, but part of the use of those measurements is to initialize and to try to describe and try to allow us to project what's going to happen in the future. So I think that the demand is there. Whether the funding is, and we did have some freedom to decide how much funding to allocate from our budgets to these activities related to others. But I think the point is, though, to try and decide what is critical and what is most urgent. There are more questions here, and I would like to Oh, Tim, if you're ready, then by all means, please.
Well, I was going to make some comments. I think forcings are, this is a very tractable problem to get a better and more timely specification of forcings. I think it has a lot of uses, and I think we should just go ahead and do that. On the wider issue of operational projections, I actually think the biggest issue is with the users and indeed the business case, as Paco phrases it. And I'll give an analogy from seasonal prediction. The biggest interest in a seasonal forecast is at the end of a big climate anomaly. So if there's been a drought that's been going on for a long period of time, as it goes on and on, people get more and more worried about, is this drought going to end? What's the forecast? What's the forecast? And I think in terms of climate projections, if the observed trajectory of temperatures and weather patterns are in line with expectations, then everyone's quite happy with the status quo, or at least is content with the information they have. But it's where the observations are pushing outside the range that was expected that the interest becomes very strong. And that could be true, quite some years ago we had the so-called hiatus, not much of a hiatus in global warming. Recently we've had an apparent acceleration of warming and global temperatures pushing outside the range of what was expected. Debate on whether that's consistent with the models or not. And it's suddenly a very, very big question. Are our climate projections credible anymore? Are the feedbacks in the system, maybe with cloud aerosol feedbacks over the oceans, or maybe other feedbacks that we don't understand, are they really invalidating the approximations we have? So the question is, I guess, for a user who might be using CMIP6 or indeed even CMIP5 projections, did the recent observations change what the decisions that need to be made? Do you need to accelerate your adaptation plans or not? Or is it just a blip? And will it go back to the trajectory one? That becomes a really critical question. And I guess from a science point of view, the question is, well, can you answer that even with the projections you have? Do you need to run new projections to do that? What is the best way to answer that question? And at some point, being able to run up-to-date model simulations and projections might be a really key part of addressing that and updating things, but it might not be the only tool you have. And I think if you come at it from the questions the users need to know, what is the best way to address those, and to have methods to to assess, do you need to update your projections? And if so, can you do it just with some sort of rejiggling of the information you already have? Do you need to run new simulations? And building a sort of system for managing that is a big challenge, I think. But it's perhaps needs more than just saying we're going to crank a handle every year. I think the users perhaps, there's more pointed questions that the users might have.
Thank you, Tim. We only have 2 minutes left. We have a couple of hands up. Okay. Let's quickly, but let's keep an eye on a time. So please.
Okay, I think that it has been really inspiring talk, and I really think that the team introduction was really important to understand the importance of the forcing, indeed, for this change of paradigm and the difference of destination Earth compared with what we have been working until now. But one of the question for me now is at the end, what we really want is to accelerate adaptation. And my question is how we can sell this change of paradigm of destination Earth and operationalization of these projections to the end user so that they can really see the added value of these projections, because I think that they were having previously a misunderstanding of several global projections, regional projections, downscaling projections, and now this change has made them ask even more questions about what I have to use. And I think that the question for me is, have you made any comparison on specific indexes or specific regions to see the added value and see why it's important to accelerate adaptation, this operationalization of climate projections? That is my question.
When people are used to get weather forecasts, so today's Wednesday, we'll start having weather forecasts for the weekend, for Saturday and Sunday. Tomorrow we'll have again another weather forecast for the weekend. Most likely saying that it's going to be warm around here. And on Friday, we'll get another one. And people have learned over the years how to deal with this information that is overlapping for different kind of decisions that they need to do. So they know that the information is given for the future and is overlapping all the time. And the decisions might change because the forecast for the weekend on Thursday or Friday might be different to the one that was done on Wednesday. That doesn't invalidate the forecast that was made on Wednesday or the one that will be made on Friday. Why can't we do the same thing with the projections? The problem is that it's much more expensive, but why cannot we do it? Because if we think of Eurocortex and the problems that were known in Eurocortex about the aerosols, we've known this thing already for 7, 8 years, and we still don't have updated Eurocortex simulations. And they are in C3S, an operational system that is delivering data that we know has problems and difficulties. 7 years with data that is not fit for purpose. Why do we need to wait 7 years or more to get something updated? Would you accept the same thing in weather forecasting? You wouldn't. In climate projection, it's the same thing. The decisions are even more important, and adaptation requires information that is updated as quickly as possible according to the needs of the users.
I'm not saying, I think that we have to sell that change of paradigm, especially to the people that is, I think that the municipalities indeed, they are asking for information indeed that's up to date, and they are more important for the coming years rather than for what is happening in the long term. So I'm sure that destination added value is clear for me. But what I'm saying is that we really need to sell that in an appropriate way, because otherwise there is a misunderstanding and a confusing understanding of what is the added value of destination Earth compared with other type of projections, long-term projections.
No, you're right. I think for now we didn't, I mean, because it's emerging, we don't have enough studies which are demonstrating this added value, and this is important. So the more frequent update is one, but the other one is really this global consistency. So even if in terms of mean climate, it's similar to what we had before, the fact that you have the local granularity, that you don't need to downscale everywhere because you have 5 kilometer consistent data everywhere in the world, that's an added value. And you should watch, hopefully, once we sort out some issues about data, whatever, for the journal, Paco has submitted a paper to GMD, which is now in discussions about data, how the data is available, etc. But hopefully over the next weeks you should see this preprint. And there is the first study where we try to describe the system and give glimpses of where the added value is. But there is a series of papers on specifically these aspects. And I see Stefan there, he wanted to add something. I don't know if it was on that, but Stefan is one of the people who are working on the applications in the climate digital twin, looking at specific aspects where you can expect added value like hydrology.
Just to close the topic brought here, I think the program level can put forward arguments on quantitative comparisons and assessments. However, how you persuade the municipality, how you persuade users is not as straightforward as that. I think in each case, the person who needs to do the persuading needs to take into account the context of each user. You can't just go and patronizingly say, oh, well, this is better for you, I know better than you. So I think that's an important angle. And we shouldn't be looking for universal answers to how to persuade these people. This is the job we all have to do together. Does anybody else have to add something really critical? Because, okay, Stefan, because we are running out of time.
Yeah, it's a yes-no question, so it will be quick. I was surprised that you didn't mention the buzzword of what-if scenarios, which all puts it all in a nutshell to say, like, we are going to make workflows for users that we will change according to user needs. Because they have the question, what if I do something? What if I invest in something? What will happen? What will turn out? So my question is, do we know, I mean, I don't know, but maybe you know. So do you know what the limit is of what we can do in terms of these like what-if scenarios and what-if questions?
It's a good point, and I wanted to bring it earlier, but then I forgot. That's one of the key points of these digital twins, that they are not only to produce regular simulations, but is to answer what-if scenarios. Now, the limitation comes related to the computing time, of course, because these simulations are expensive, but what-if scenarios are not only at the point of running the whole model again, but running the impact sector models with data which is streamed from the climate DT. So I think there are various types of what-if scenarios. The global ones, of course, you can do a few, and that's the idea, that if there is a new question that Europe has, you know, collectively, of how certain policy can be translated into a forcing, and that needs another type of work as well for the future forcings. But then much more can be done at the local level, and yet more can be done with machine learning. And that's why we have also started in Destination Earth to build a climate emulator, because hopefully this will increase the ability to do much more what-if scenarios. And there is also another type of what-if scenarios which is done in Destination Earth, which is focusing on extreme events, replaying extreme events of the past years from 2017 on until present day in different states of climate, and this can nicely feed into the attribution efforts which are done in C3S, for example. So there are many flavors of what-if scenarios. Thanks for bringing that up.
Thank you all. Thank you, the panelists. Thank you, those who woke up early and took part in this. Let's keep talking over the next coffee break. I don't think it's next, so I'm going to let Carlo take it over from here.
just a quick announcement. There is coffee break. Please don't forget to fill the survey. It's on the registration desk. Your feedback about the General Assembly. And for those online, there is a QR code that you can scan and take you to the survey. It's very important. We have reacted to your feedback last time, and we are keen to do the same this year. So don't forget to do it over coffee break. Thank you.
Hi, everyone. Panel call for grants. Thank you, Sam.
For C3S General Assembly. So, as this is a new opportunity for C3S, and under the NCP, supporting the European Commission's let us deliver grants for the first time. And it's a really important step because it allows the ownership of IP to be kept by the member states who are actually implementing the grants. So it's a very different service mechanism. So before I start, so I'm presenting, but there's a big team behind us. So the NCP team, Christina, Delphine, but also importantly, we have two new grants officers, Laura and Tommaso. So I don't know if they're in the room, but if they want to put their hand up. So if there's any questions about implementation of grants, please pick on those two because I'm interested in the technical level. Any complicated questions, please pick on those two. So the NCP was introduced by Christina on Monday, so I'm not really going to go into that. I'm just going to talk about the new opportunities that are arising in the next couple of minutes. So the objective of the NCP is to promote the uptake of C3S products, services at the national level and make them fit for purpose. And we do this through the National Collaboration Programme. And through the National Collaboration Programme, we have a series of bilaterals, user workshops, NCP forums, and we gather the needs, requirements, and then we distill a series of either ITTs or now grants to try to implement the user's needs and requirements for uptake of C3S services. And in this month, hopefully this month, we will be launching the first call for proposals, and this will be the grants, and it'll be based upon a number of predefined actions that have been informed by these bilaterals, workshops, dialogues with users. So the first action is the direct use of C3S products at the national level. And this is a really, really open, vague call. So you can use any information coming from C3S and incorporate it into your own workflows. And the idea is that we're fostering the development of climate services, making C3S products relevant to national needs and requirements. And here we're not really funding research, it's not the purpose, but we're really going the last mile to deliver tailored, co-developed solutions at the national level. And here you would see some figures. So each of the grants will be about 120 to 200K, and we aim to fund 3 of these grants under this action. The next action is to support Paul Polly's activities on data rescue, and I would like to thank Paul for supporting the wording of this grant action. And the idea is that we're making available, previously unavailable weather observations and bringing those into the C3S data rescue activities. And here is the indicative number of grants and the value. But we really do encourage any of those National Met Services, any other entities involved in Copernicus to be on the lookout for this grant to support data rescue. The third, in a new activity under the grants umbrella, is transboundary cooperation. And here we're looking to bring countries together who have geographical common interests to use C3S data to develop solutions for the region. And this is a new initiative and is, again, being informed by member states' requests and various dialogues through Carlo's tour of the countries, but also the forum and NCP. And we are looking to develop, fund 3 of these activities, and this has a slightly higher value because we're really trying to bring in at least 2 or 3 different actors across the region to develop regional solutions. And quite interestingly, we've been approved by the European Commission to include third-party countries at no cost. So those states that aren't part of Copernicus could be eligible for inclusion in these activities at no cost. fourth is twinning, and there's a key requirement for bringing some countries with less developed capabilities up to a particular standard to improve their climate resilience. And here we're twinning countries with mature climate services with those who need support to develop their own activities. And this twinning activity will involve 2 or more actors. They don't have to be geographically close. They could be either side of the continent. But it's really a transnational cooperation. We propose to fund 3 activities with about 150 to 300K. And the 5th action is on learning and training. And this is a key requirement, again, who's emerging from the dialogues about how we can support those countries promote the uptake of C3S products, either through training their own workforce or training particular sectors that need to use C3S data. For example, we can look at students, for example, or more importantly, to support climate adaptation and develop frameworks and policies to support policies, how they can incorporate C3S into their workflows. So that is really the overview. I had 5 minutes. There's a lot of information there on the slides, but I really just want to encourage you to be aware of these opportunities. Later on, we have the NCP forum, and the delegated authorities, each of the countries will be in attendance. And I know there is not always a correlation between the people in the NCP forum and the National Met Services, the hydrographical services in your individual countries. So please come and speak to us if you need to access to your focal point, and really just to start to think about these opportunities that can support actions from the NCP. And here's just a quick slide to talk about the common implementation principles that are really underpinning the whole NCP process. So I appreciate there's a lot of information there. I only had 5 minutes to pass this all on. So if there's any questions, please feel free to come speak to me or my colleagues after this session, and we can talk about the details of the call. Delphine, over to you.
Thank you. So now we're going to have a little dialogue, and I would like to invite the perspective of Greece, Spain, and Denmark. Mayalen Iturbide, she's an environmental scientist in the Climate and Data Science Group at the Institute of Physics of Cantabria in Spain, where she works on the post-processing and regionalization of climate data. She is part of the team responsible for generating regional climate change scenarios as part of the Spanish National Adaptation Plan. And she is also the service manager of the Spanish NCP project that kicked off last November. Then Stergios Kartsios. So Stergios is a postdoctoral researcher at the Remote Sensing of Aerosols Clouds and Trace Gases group at the National Observatory of Athens and at the Aristotle University of Thessaloniki in Greece. So his expertise lies in numerical weather prediction, fire-atmosphere interaction, and regional climate modeling. And he's the service manager of the Greek NCP project called Climate Hub that also kicked off in last November. And then Mark Payne. So Mark is a climate service practitioner from the Danish Meteorological Institute in Copenhagen. He's the scientific coordinator of the Danish National Climate Atlas, and his role, he's responsible for a climate service that is used as the scientific basis for climate adaptation plan in over 90% of municipalities in Denmark, as well as in the state and private sector. At the same time, he is the scientific lead on a development project with the Ghana Meteorological Agency that has recently led to their first climate service, Climate Atlas Ghana. Thank you very much, and I would like also to invite Carlo on the stage. So to start, I would like to ask Mayalen and Stergios to introduce a little bit their project, and I believe that they have slides. So over to you, Mayalen, and could we have the slide in Spain, please?
Thank you, Delphine. Yes, our project is titled Enhancing Drought and Fire Weather Climate Services in Spain with Regionalized Seasonal Predictions based on C3S products, and we chose this project because of several reasons. First, forest and droughts are two of the main risks that are expected to intensify as a consequence of global warming. And because of this, we need strong early warning systems to elaborate adaptation plans and to take actions in advance. IMET provides already short-range fire risk forecasts and drought monitoring services, but including seasonal information, it's crucial for instance, water resources management or taking actions in advance for forest fires. So currently, there is a new phase of Spanish National Climate Services under development through the collaboration of IMET and also the platform of climate and climate services of CSIC, the Spanish National Research Council. Actually, this project is carried out by both institutions. And in this new phase, there are a lot of developments. We plan to develop 10 thematic services, and it will cover different timescales. And this also includes seasonal forecasts. However, we know that we know that this is very challenging because, well, among other things, giving relevance to seasonal forecasts at the regional level is complex because models are too coarse at this level, biases must be corrected, and methods are complex, communicating uncertainties, scale everything, it's also a difficult task. So with this project, we aim to contribute to this new phase of new developments of climate services through or focusing on the development of an operational framework for regionalized seasonal forecasting of fire risk and drought conditions. To do so, we use C3S data, of course, the multi-system forecasts, the RFI reanalysis, and we combine this with national observations for applying different downscaling methods. We are studying different strategies for downscaling, applying downscaling methods in the context of seasonal forecasting and the particular case of droughts and fire risks. So finally, this workflow, this development will be integrated into the framework of operational services of the national operational services of Spain. So the added value of the C3S, it's important for us because it provides a high-quality, trusted foundation, not only for feeding out services with different indices or, yes, these particular climate indices, but also for training the downscaling methods. That's all.
Thank you. Yes, indeed, I wanted to ask, but thank you very much. So, Stergios, please tell us a little bit more about your project and what is the added value of C3S.
So, hello everyone, thank you Delphine. Our project is titled Climate Hub, and it seeks to, let's say, develop smart climate services for national authorities. Currently, we are working on the seasonal and decadal forecasts based on and we target renewable energy sources. And by that means that we are going to develop an energy demand model for the next season, and also wind and solar power generation forecasts also for the next season. We utilize the ensemble seasonal forecasts and the time from the C3S data store, And also we have on board the Hellenic Space Center, which is endorsed by the Ministry of Governance. We have the support of the Ministry of the Environment, and also the Academy of Athens, that is also our partner. This is our scope, and our main goal is to have all this information publicly available. And also, we found a gap that with respect to the information beyond the traditional, let's say, meteorological lead times with respect to energy management. So this is, in a nutshell, our project, and we hope to transfer this know-how and this, let's say, experience that we will gain from this to other sectors like agriculture, tourism, and so on. And the tipping point, I would say, is that we aim to, let's say, enhance Greece's resilience to climate change and also to further develop adaptations measures with regard to climate vulnerability. Thank you.
Thank you. So now we invited Mark to also give his perspective from a country that has a very mature climate service. So Mark, how do you see the NCP especially contributing to Denmark?
Thanks, Delphine. To try and answer your question, I put together this slide. And our experience with developing climate services in Denmark is really a tale of two climate services. And that's because we started doing this 8 years ago in 2018. And that's actually what you can see over on the left-hand side as you look at it here, where we developed our Climate Atlas, our National Climate Atlas. And back in 2018, I won't say it was before Copernicus, but Copernicus wasn't as developed as it was today. And we did it ourselves. We did everything ourselves, starting from Codex and ESGF and our own data sets. And that was great, and it worked well. And today it's used by over 90% of municipalities in the development of their adaptation plans. But then we actually have also been involved in a development project with Ghana, where we've actually essentially replicated what we've done. And that's what you can see over here on the right-hand side. And within the last few months, and we've only been doing that for a year and a half. And within that time, they were able to go from nothing to an online climate atlas based on our guidance. But we actually chose to build that with them based on Copernicus data. And the reason why we've used these two very different approaches is, first of all, the time difference and the evolution of Copernicus, but also the fact that Copernicus adds value, a tremendous amount of value to the raw data. And that's actually what you can see sitting behind me. It's this quality control aspect. It's the provision of DOIs. It's the clarity and transparency of what you're getting. It's the traceability that is much, much more attractive than working directly from Codex data. So what will happen for our Danish Climate Atlas is in the process of the next year or two, we'll actually start transitioning it to Codex data, and particularly once the new generation of Codex comes online. So to answer the question, the value in Copernicus is really this role as a gatekeeper and as a source of data, of high quality, assured data, on which you can build a climate service.
Thank you. So through the NCP, we've had already multiple bilateral exchange, and what came up is really the need for national production at high resolution. So I would like to ask you, the three of you, your views on how the NCP can support the development of national projection. Who wants to start?
So, can you hear me? No, it's not. It's on. It's on. Okay. In Greece, there are some projects that have started with respect to the protection of climate projections, but most of them are, let's say, use dynamical downscaling methods. So as all you know here, dynamical downscaling methods require a lot of computational resources that are partly available in Greece. And the new HPC system, which will be launched in the end of the next year, will offer some opportunities in this. But I think that beside these approaches, also the recent advances in AI and ML techniques must be considered with respect to this production of climate projections. But these also approaches require computational resources. So I think that the most important thing that NCP can contribute to the countries that will want to produce their own climate projections is to let's say, to have to create a link between HPC systems around Europe into countries that they do not have these resources to create their own climate projections. Thank you.
Thanks. Mayelen.
Yes, so one of the line of actions within the Spanish National Adaptation Plan is elaborating these regional climate projections. We are doing it already. It is delivered already for the users through an interactive web application. And now we are already using downscaling advanced machine learning techniques to also have products from the statistical part, let's say. These outputs will be made available in the coming weeks, by the way. And I think that apart or besides that what you say regarding infrastructure and computational resources, I think that another thing that the NCP could or can do would be to promote collaboration between neighboring countries so we can share experience, learn lessons, perhaps share the methods. And besides, I think that having a higher resolution reanalysis, it's an opportunity to elaborate more coordinated frameworks for generating these regional climate projections.
Thanks. Mark.
I already touched on the fact that Copernicus can really have this powerful role as a guardian and a gatekeeper of data. In Denmark, we are a small country and resources are limited, and we're very happy to stand on the shoulders of giants like Carlo. And I think that's a really, yeah, exactly. That's a really, really important role. But the other thing that I think sometimes we also think of, there's a danger in thinking about Copernicus as only data. And in fact, what Copernicus is there are 200 people in front of us here, because Copernicus can also act as a community and facilitate exchange of ideas and experiences, particularly in the climate services domain. What we see in Europe is we see 27 countries that are doing essentially the same thing. And Copernicus is a mechanism that can actually, where we can learn from each other and where we can exchange data, code, and ideas.
Yeah, thank you. And on this, Carlo, how do you see then C3S fostering the coherence of the climate service?
Yeah, thank you for the question, Delphine. Also because allow me to stop nodding when Mark is talking. It's hurting my neck. No, thank you for the kind word and thank you for the example. in a sense, I do see the NCP as really playing this fundamental role in the handshaking between the international level and the national level. And this handshaking has several aspects. One aspect is translation, if you want, and not translation in the local language, translation in the local context, in the priorities, in the modus operandi, and so on. And the other one is an upscaling mechanism. So understanding what is required at the national level to then have a pan-European approach to it. And as you were saying, I think in terms of climate projections and scenarios at national level, I think there is quite a bit that we can do, quite a bit more that we can do. Because if you look at the landscape in Europe, as you were saying, there are 27 different solutions that actually at the moment do not talk to one another. So the first point, the starting point for me is ensuring that we can start from the same base. It can be Cordex, can be CMIP, can be anything else, the gridded observation and so on. But then also ensure that the different experiences can be coordinated at the European level so that we can go towards sort of standardized set of reference data set for Europe that can be the basis for everyone to work on. And already in this phase of the NCPs, I think there are things that can help in that process. I mean, you were making the example of the downscaling that has been done here in Spain. And in Spain, I think it's really one step ahead of many other countries in Europe in terms of complexity and richness of the downscaling methodology. Well, the twinning that Sam was presenting before between countries could be an opportunity for others to pick up from what you have done and develop their own proposition. And one of the challenges I see, an important challenge for NCPs in the future, in the next phase, is how to ensure the coordination of these experiences. Because we should avoid the NCPs to be something that makes a proliferation of small solutions for small countries, but more as an aggregator of experiences that are specific to different countries, but that can then be expanded and coordinated at European level.
Thank you. So we will also open the floor to questions, but I would like to ask also what would be your priority or recommendation actually for the next phase of C3S, if you have some specific priorities. Mayalen. Oh. You.
That's my name. So one of the priorities, I think, would be, and I'm talking because of the experience that we are having now in the development of the project that I have just presented, would be aligned to the plans for increasing the uptake of C3S products, I think, and in particular, regarding the user experience when accessing data from the CDS. So priority would be to continue the work that it's already being done and perhaps extend it to let's say, improve the reliability and usability of the data access, especially for projects like ours, where we need huge amounts of data, not only for feeding the different services, but also for validating and training downscaling models and so on.
Thank you.
Yeah, I think that the experience, the know-how that we gained from this project so far would be a nice point to continue what we are doing right now with respect to seasonal or even decadal timescales. But also we are thinking about utilizing this opportunity of workshops of training that has to be done also in national level, but also in regional level. So I think that the Action 5 with respect to the training and it will be a nice link between what we are doing and how we can disseminate this information to stakeholders and national authorities. Thank you.
Thanks. Mark.
I think the national voice is very important to have in future iterations of Copernicus, and we've started that dialogue here, and I think that's really, really good. But one voice that I actually don't hear is the Global South, and I think Copernicus can really be a tremendous power for good also in the Global South. And you've seen the example that we've done based on Copernicus data in Ghana, and there is so much that we were able to do that we couldn't have done 5 years ago because this climate data store existed. And I'd like to see that developed and pushed further. Very, very simple things like moving the processing load actually onto Copernicus servers, circumventing the bandwidth bottleneck is a tremendous value. The entire institute of the Ghana Met Agency runs on a 10 megabit connection. So the way that we got the data to them was we downloaded it ourselves, we cut it out, we put it on a hard disk and flew to Ghana. And that is not an option that every institute in Africa has. So anything that can be done to just the basic things like cutouts and pre-processing on the server side rather than on the user side is tremendous benefit for Africa. And if you really ask me to make a wish to Santa Claus, mixing my languages, to Santa Claus is what he's called in English. I would wish for a Copernicus African regional reanalysis. We have Sarah, we have Kara. I'd like to see CAFRA.
Thank you.
Well, the first, I mean, again, I think I will need to find the physio after the session for my neck. I completely agree with what you're saying, and it's hard to underestimate the bandwidth of sending disk to the world. So we move our archive from Reading to Italy, and that was of the order of an exabyte, and there were a few lorry full of disk. And it took just a day. And you're moving an exabyte in a day. It's quite remarkable. So don't underestimate the importance of shipping a disk around. But it's not the most. It's not really a solution that is scalable. That's the key element. And in that sense, I completely agree with you. I think that the solution that we have in place that is largely cloud-based reduces that bottleneck significantly. And there is a potential for massive expansion in the Global South. Of not expansion as in trying to colonize the Global South, but rather an opportunity for the Global South to take advantage of the public investment that has gone into the service to build their value-added solution. And I guess this is one of the possible, and the next, panel, the next discussion here that will follow just this panel is about the evolution of the service. And one of the possibilities on the table is to increase the reach of the service proactively outside of Europe. At the moment, our user base is mostly Europe and Asia. Asia actually is very big for us, much less so in South America and Africa. So looking at the possibility of supporting development of climate services proactively in Africa and South America is something we are considering. And clearly this is part of the discussion that is already ongoing with the member state and the Commission.
Thank you. I would like to open the floor to questions, and also we will have the NCP forum this afternoon, so I think there are many other representatives from other countries, and maybe we could hear other perspective if you want to say something. Yes.
Okay, thank you very much. Obviously, I support NCP, as you know from the beginning, that not only in my case, it's representing AMET, in all members that is attending the Copernicus User Forum, we are supporting these initiatives because it's the best way to ensure the well connections between the countries and the members and the what regional is in the international scale is doing, and then I fully agree. And then if we move back to the last slide that just said regarding the 5 principles, if we are thinking about the NCP, I'm sure that we can answer or we can achieve any target and we can follow these principles because NCP is supporting this. It's not only the downscaling, we are improving the visibility, we are improving the connection in a national level or I say supranational or transboundary level, it doesn't matter what is the words. But I'm concerned about one issue because we have the experience that how many developments has been doing. We need to know that NCP is not only from C3S, we are talking about this. NCP is in camps, in land, in emergency, and if we close our eyes, we need to bear in mind that in the next phase, we need to think about how can coordinate all developments, not only inside C3S, is with all NCP, because I'm sure that we can, I don't know, we can create a big monster in a good sense, not in a bad sense, that because our target is to create a good services for the citizens, but not create maybe a chaos of services that is maybe difficult. My concern, I want to share with you, how can coordinate this? Maybe the member will need to say something, obviously the European Commission, obviously the Copernicus User Forum, the Copernicus component. This is thank you very much.
Thank you. I see also in the back and then in the front, 2 questions. And someone in the back had a question. Yeah,
Thank you. It's more a comment in a sense that let's not forget that for the NCPs, I think one of the very important factors is actually that in all the European countries, someone gets to present it as a national, let's say, information asset. Because in many cases, the why something is not being taken up is that it's not necessarily stamped as approved in this country. So I think one of the action is to try to together, I think Carlo is correct in the sense we should all be on the same level and support the full same system. But in many cases, in some countries, it's even legally only okay if the national entity responsible for it is doing it. And convincing these entities, and at least in the more developed countries, is actually difficult in the sense that we already have our systems. Why should we use someone else's information? So NCP funding and this system should also be convincing to together solve the systems in the same way. But I think this is on a good way. So let's work for that. Thank you.
But I want to add that also the aim is not to replace, but to fill a gap. So that's why we want to address, I mean, the context in different countries vary and the gap, the needs differ. Thank you. Hugo. This in the front. Oh, yeah, of course.
Okay. Thank you, Delphine. Yes, now, well, it's, I think, now my turn to stop nodding. I would agree to a large extent to many of the things that were said here. I would like maybe to emphasize for us, it's important really to understand as well these NCP activities along all these vectors you have explained. For us is kind of the glue between the activities at the European level in the Copernicus program, and to make sure all these things connect well to that what the member states are doing on their level. So this is, I mean, you evoked that yourself as well, and I think that's for me the essence of this activity at all. No? So I'm very glad that you said that about the other services, not me. So, but I happily take that up. Clearly, that's something we need to organize in order to even more have more synergies between all these activities. And in particular, I would like as well to encourage you to think about. Now that's the third point. To think about these cross-border issues. So where do we have member states who share maybe common issues where there's something to be gained if you have a common approach and so on and so forth? So this is very much the case. Yeah. Okay, thank you.
Thank you. Thank you. Yes, more question. Yeah, here, please.
So thank you very much. I would like to take this opportunity to say a few words about the National Collaboration Program. I come from Bulgaria, the National Institute of Meteorology and Hydrology, and I will attend the afternoon event of the NCP C3S. I just want to say that how important the NCP is for countries like Bulgaria. We last year finished project under the National Collaboration Program CAMS, and now we are entering the second phase of the same with another continuation of the same project. And we really hope that for climate change services will also have the same impact for the country. I just want to stress that for countries like Bulgaria, the National Collaboration Program, what it gives is, it provides additional structure. And so we really focus on things that we may do in the country, even if we don't really need funding for them. The National Collaboration Program, with the influence that the Copernicus program, the Climate Change Service CAMS can have, give us more focus on the things that we can develop at home. And from that perspective, it's very, very important. Thank you.
Thank you very much. Very good to hear. I think, so who wants to go next? I think Samira.
Okay. Thank you very much.
And I was told we will take another 3 questions and then we will move on to the next session.
Okay. So good morning here, Samira Kodayar from the Mediterranean Center of Environmental Studies here in Valencia. I would like just to come back to the words that have been said at the last discussion on the table and also continued in the discussion through the whole. So I think it's, of course, very important to go on the internationalization of Copernicus. Definitely, it's also considering Global South and other regions, but still, I believe there's a lot to do still in areas like, for example, the Euro-Mediterranean. I think the many disparities that we have in the Mediterranean still have to be considered, and communication and collaboration have to be further strengthened.
Thank you.
Can I react very rapidly to this point? Just to mention the ongoing collaboration that we have with the Union for the Mediterranean, and actually we've funded a few case studies that bring together the two sides of, north and south of the Mediterranean, looking at specific cases. So I completely take your point. We're discussing about the possible expansion beyond Europe, but there is a lot to do in Europe that we're already active on.
Thank you.
Hi, so yeah, from the Irish Met Service, and you mentioned there that ways of helping countries downscale data to get their own national projections. For countries that already have their own national projections, there are a lot of tools that Copernicus provide that we can't really take advantage of without integrating the data into the C3S or the CDS data store. So is there plans to integrate the national projections that already exist into these systems so we can take advantage of the tools that Copernicus provide?
I react. Yes, well, to some extent, this is partly already addressed by one of the actions that Sam was talking about, exchanging data and facilitating the uptake of national data. I guess it also touches on the other point I was referring to, and it's this fact that we have often different projections or different climate scenarios at national level and international level, or European level. And I think that's a work in progress. We are not quite there, but I think it's clear where we should be going. And we see already, for instance, in Central Europe, coordination between Austria, Germany, Switzerland on climate projection. And this is, I think, is a good example that we could try to follow. And the National Collaboration Program, in particular, a transboundary call, can be a mechanism to foster that sort of path toward a standard data set for climate projection in Europe.
Maybe one more question. Okay, two more. One in the front and one in the back.
Okay, thank you. My name is Carlos. I'm from Portugal, from the Portuguese Institute for the Sea and Atmosphere. We have been working in the Global South in some projects in Angola, and we have been providing in the southern of Angola some of the Copernicus products, for example, ERA5 reanalysis and other data sets. And it has been very well received by the Angolan community. So I think, and I received with very happiness the news of possible local reanalysis for Africa and the expansion of these national collaborative programs as well for Africa. I know that there's a lot to do still here in Europe, and the challenges for Africa are even bigger because they don't have so much synergy between countries as we have here in Europe. But I think it will be very nice to see this program applied outside Europe in Africa, which is a very, very lack of weather station country, lack of observations. They have a lot of challenges on these matters. So yeah, thank you very much.
Thank you. So, yeah, sorry.
I can maybe complement that with a little story from my first trip to Accra in Ghana. And we were walking around touring the institute, and one of the forecasters from the ocean department sort of dragged me aside and sort of had a hushed, quiet, secretive conversation. Do you know where I can get some sea surface temperature data? and of course the answer is, yeah, you go to Copernicus and you download it. But in Ghana, you don't just do that. And as an example of the ocean forecasting is driven entirely without any satellite products. I don't know how it works. Yet for us, it's such a simple thing to do. So there is such tremendous gains that can be made in the Global South for relatively little investment.
Thank you.
Thank you. I'm the sovereign manager of the Italy NCP C3S or NCP. Just a comment. For us, for Italy, the opportunity given by NCP is to increase the visibility of the possibility that C3S can give to operational use of this data into operational workflows. So the idea is to integrate the opportunity, the product given by C3S into something that's need to be operational. At the same time, we wanted to coordinate this operational use of this data. So to avoid that different services run the different downscaling, or maybe it's good to have different downscaling, but it's also extremely useful to have coordination about the different downscaling done at the national and regional level. And one point that we tried to do at the Italian level is to coordinate the NCP for the different services. At the moment, we have 3 NCP runnings that the second phase comes, the C3S and CLMS. So we are trying to coordinate this at national level. So I agree with the user suggestion that also the services should be more coordinated among them to have this will be a given support for the member state as well. Thank you.
Thank you. So with this, I think we can move on to the next session on the next phase of Copernicus. Thank you very much.
Yeah, I was quite relaxed about overrunning a bit this session because I was going to speak at the following session, so I was sure the next speaker was not going to be worried about. The good news is that it's only half an hour and then we wrap up the GA. The maybe less good news is that it's going to be me most of this half an hour. But I thought it was important to, before we finish and we part, to give you a bit of an overview of where we are in our journey to the next phase of Copernicus. So, as you know, we are now in phase 2, and we are midway through this MFF, but discussion has clearly already started about the next phase, the phase that will start in 2028 and will continue into 2035. And what I'll try to do is to give you a bit of an overview of where we are in the discussion, of some of the ideas, and I will be happy to take a few questions before wrapping up. It's very early stage, so nothing is set in stone. It's really in a state of flow, but I was keen to expose you to those initial thoughts. If I can have my, yeah, great, brilliant. The less good news is that I decided not to reuse my old slide, but rather to put together new slides. And I've done this between the drinking session of yesterday evening and the swim in the sea this morning. So if you spot some inconsistency, strange use of the language, or errors, well, you know why. So let's start. Well, the first point to mention is that actually we have a very difficult task in front of us, because we don't yet know what is the envelope in which we will be operating. So we need to plan with big uncertainties that are coming from the socioeconomic situation, uncertainties that are coming from the political setting, uncertainties that are coming from the innovation and evolution. I will say something more about those. So the way in which we tackle this in Copernicus, not just in C3S, but across all services, has been to develop a non-paper, and this non-paper, each service has a non-paper, and this is structured over 3 plausible scenarios. Scenarios of continuity, that is pretty much the current budget, maybe with some correction for inflation, sort of enhanced continuity, where actually there is potentially an expansion of some area of the different programs, and then high ambition, so where actually certain part of the program can be expanded further. We don't know where we are in this scenario, so which one of those will be the one that will be chosen. So we need to have a very flexible approaches. We need to follow flexible approaches where certain things can be scaled up or down depending on the political and economic constraint. And we looked at the building blocks of the service, and unsurprisingly, and that's also what we have done in this GA, we started from climate observation. So there are certain points that are quite solid in our mind, and observation is very solid, it's very close to our heart. We want to continue our work in observation, satellite observation for sure, because satellite is our bread and butter, is what is the Copernicus program all about, but also in situ. So we mentioned, and we started even on the first day, talking about the importance of data rescue. Data rescue adds value to our ability to describe the climate of the past, adds value to our reanalysis, and is something we need to do, and we didn't possibly to do more of, to pay our fair share in the international effort towards securing this long-term climate data set. So it's something we are keen to do, and keen to do in close coordination with the other services and potentially expanding on. The second point, and I think it's an important one, we heard about the evolution on the directive for a high valuable data set, and the fact that there is pressure coming from legislation in making observation available. Well, we want to support that process as a Copernicus and ensure that climate observation can be served directly to users. So that's something that will feature into the evolution of the program. We heard this morning from Peter about the evolution of the GCAS ECVs. GCAS ECVs will continue to be one of the building blocks of the service in all scenarios, but we want really to use that to the full extent. So we heard about the 55 ECVs this morning, the fact that we are reducing those or rationalizing those to this sort of 19 ECVs with the same number of ECV quantities. Well, we would ideally like to have as many of them, possibly all of them, available. So having a climate data record for the vastest set of ECVs in as close possible to near real time. For some variable, like we have done it for the climate poles, for SSTs and global mean temperature, near real time can be achieved quite easily. For other variables, you think about glaciers, you think about above ground biomass, maybe more difficult. Nevertheless, the aspiration and the goal in the long term is quite clear. If we look at climate reanalysis, and you see a lot of dots here, because this is one of the moments where we are actually facing a fundamental uncertainty. So we started approaching the idea of global reanalysis evolution as a continuous or progressive increment on the past. So we got era 40, era interim, era 5, well, era 6 now, that basically is starting now. Era 7 will be more of the same. We have seen from Paul the extrapolation of the resolution, so you can imagine a global reanalysis at sort of sub 10 kilometers, probably around 7 kilometers resolution, fully coupled. So one of the innovations of era 6 is the coupling with the ocean. The natural evolution is to have the coupling with the land as well. And we actually have started investing in that direction. So Cerise project that has been mentioned in some of the slides today is building our capability to do that. But, ... this is not a given that the next reanalysis will be physically based. We had a discussion yesterday afternoon about machine learning. Well, it's really a big change. And so we need to keep our eyes, ears, and mind open to the possibility that era 7 could be a different beast altogether. This is true for the global reanalysis, and to some extent is true also for regional, well, in some sense even more true for regional reanalysis. For regional reanalysis, the starting idea was to go higher resolution and maintain a physical base model, but focus mostly on the assimilation of unconventional observation. Unconventional observation in this case means many things. It means, for instance, the radar network that is not ingested, is not ingested in era 5, but could also be potentially Internet of Things, citizen observation, and so on. So this could be a way for regional reanalysis to really add value at the physical processes with the aim of developing high resolution reference observational data set for Europe, which in itself can become an asset for machine learning and for exploitation downstream. The final point is that almost irrespective of our decision, we are going to move in a situation where there will be multiple reanalysis. So one of the possibilities on the table is to have a climate reanalysis, like a long-term stability and so on the one hand, and maybe a short-term, frequently updated reanalysis in support for machine learning, for instance. This is one of the things we are considering. At the regional level, well, at the global level still, we are already engaged with WMO as a lead center for multiple climate reanalysis. So multiple climate reanalysis are already available through ECNWF website, and this will be enlarged. Well, why not doing the same for regional reanalysis? So we started a few years back. There was only one regional reanalysis. Now there are several. So the possibility of exposing the different reanalysis in the same framework is certainly something we are considering. Well, you know, citing Karl Marx may be strange in a talk on climate, but a spectre is haunting Europe, and it's not the one of communism, but is really the one of machine learning. So that's that for me is the fundamental big question mark. Those ... that we put in the slide is because this is a shift in everything we do, and this can actually alter our path in the next few months and years. On prediction and projection, and as you may have guessed, actually I've used, in the middle of the night, I've used ChatGPT and machine learning to generate the pictures, and this is a good example of why you should be careful, because I said, well, write a partial differential equation on a grid to explain what the model is, and if you look at that equation, it doesn't look right to me. So I think there is always the risk of hallucination, and we need to be careful. Again, we discussed about that yesterday. We need to be wise in the use of this innovation, but we need to be also mindful of the fact that this is coming. And we touch on the idea of using machine learning for predictions. This is happening. There are already papers coming out. So when you look at climate prediction, seasonal and decadal, I think it's a safe assumption to assume that in 5 years' time, it won't be just physical-based model. As a minimum, it will be a combination or a hybrid. and we'll need to react to that. The second point that we put in our non-paper is this idea of having a framework, a seamless, I don't like the word seamless, but just to give you an idea, a framework to put together all sorts of climate information on all time scale, from sub-seasonal to multi-decadal. Because in the eyes of many users, this distinction between the weather timescale and the climate timescale just doesn't exist. It's a continuum. And serving those users better by having a more continuous product, I think could be a real asset. Not talking about a single modeling framework. That would be very difficult to generate. I'm thinking about a framework, an interface framework to the user. The other 2 points are probably less surprising considering the discussion we had today and on the first day. On the one hand, the Atlas. We are already working on the Atlas in support of the IPCC. I put the IPCC in bracket because clearly the decision on how to support the IPCC is not a decision we can take ourselves. It's a decision that sits firmly within the IPCC and the coordinating lead authors. So the decision will come, but we are positioning ourselves to support IPCC should IPCC decide to engage with us. And the last one, again, picking up from the discussion today, is the idea that we want to support this transition towards a more sustained mode of climate projection, and the way in which C3S can contribute to that. We heard about the Destination Earth and the framework. The way in which we can contribute to that is to support the generation of forcing in a more sustained and operational fashion. In terms of value-added climate application, which is a very, very broad element. So on the one hand, we want to support and expand bespoke application, and I think you heard some of them also during the coffee break, the Climate Explorer, the Climate Pulse, the application to the GNV and so on. We want to have more of those, and again, even here, we do expect machine learning to play an important role. We started, we heard about it, we started an operational attribution service. This operational attribution service wants to stay, wants to actually be expanded in the future and connect more closely with what's happening regularly on ECNWF on the weather timescale. So links between the weather timescale and the attribution service are already in this contract, but it's something we want to expand. And one element we want to expand is the generation of counterfactual. So in the contract we are running now, there is a connection with the counterfactual that Destination Earth is generating. That's one way of doing counterfactual, but there may be others, and we need to engage with that process. And as we were discussing in the previous session, there is this idea of maybe pushing the reach, more proactively pushing the reach of C3S beyond Europe. Again, some of these options are not necessarily fully possible, depending on the envelope in which we will operate, but this is the broad concept, broad set of ideas we are considering for the Copernicus evolution. In terms of front end, which again is a very broad concept, more use of machine learning in the front end, which means a number of things. We have already a chat box that provides a very valuable interaction with our users, where that chat box actually could become an entry point that is much wider than just user support. It can be an entry point for evaluation and quality control, can be an entry point for finding data. Training, again, NCPs is very active on training. Well, potentially we want to do more training for our core user at European level, and we heard from the member state users and technical experts at the national level as well. So again, on the high end of that spectrum of possibility, having training in multiple language would be great, extremely expensive, so it needs to be leveraged depending on the available resources. But what is clear is that national collaboration are really very much valued by member state, and is something we want to work on and expand in the next phase. So what have we done? Well, since the beginning of the year, we went on a European tour, Laurence from CAMS and myself, going between European capital, presenting the plans for C3S and collecting your feedback. And then back in April, we organized a workshop during the annual seminar in Bonn, where a representative of the member state commented on our preliminary plans. So these are some pictures of some of the sessions we ran there, and we collected feedbacks. And when you ask member state for feedback on what your plans are for C3S, well, you get feedbacks, a lot of feedbacks. So at the moment, we are actually digesting all these pages and pages of comments, of suggestions, of feedbacks, alongside the feedbacks that are coming from our science team within ECNWF and our interaction with the Commission. So nothing is set in stone, but we are really looking forward to engage also with you and with all the stakeholders here in the member state to understand what is strong, what we need to strengthen further, and what actually can be left as it is now. So what are the next steps? Well, we are discussing at the moment the budget with the Commission. So we are not discussing, the Commission is discussing the budget itself. We will know maybe over the course of the next few months and years, I mean, maybe Hugo wants to step in on this point, what is the general envelope in which we'll be operating. We are elaborating this informal input we got from member states, from users, from yourself, from our experts within ECNWF, and digesting and transforming our initial ideas, this non-paper idea. So we are consolidating the non-paper. We'll prepare some communication to the Autumn Committee of ECNWF that will go to Council in December, and this will effectively provide the basis for the contribution agreement. So we are in that process. I put dotted there because there are many other steps in that process, but eventually that contribution agreement will become the basis for our legal interaction with the Commission that will be signed before we start. We do expect to start sometime in 2028, so there will be a transition period between Copernicus 2 and Copernicus 3, and take it from there. And I think that's it for me. Thank you very much. There is time for questions, but I want to also give the opportunity to Hugo to add something if you want. It's coming soon.
Yes, thank you, Carlo. So I think the main takeaway I have from the talk you just did is, of course, there are plenty of ideas, plenty of avenues which might be worse or probably are even worse to explore and so on and so forth. Indeed, all this is something we have to put in proportion at some point in time with the resources which are made available to us. No? So you said so nicely the Commission is discussing the budget. That's only half of the truth, because the Commission proposes the budget, but it's finally the Parliament and the Council of the European Union that decide on the budget. No? So there's this short saying: the Commission proposes, the Council disposes. No? So, but so we will have to see, and this means those from you which are from member states, I seriously invite you to indicate as well to your counterparts in the finance departments and so on and so forth, to indicate that these things are relevant to you, that these things are indeed worth financing, and so that your finance minister and secretaries of state and so on, they know when to recognize, that's Copernicus, I heard that before, and I raise my finger in support on that. No? So that's really, I think, something that everyone, or that you could do at national level to help us to evolve and to bring this into force. On the timing, indeed, we would expect if the Commission proposal for the next multi-annual financial framework somehow during summer, I would say. And but as I said, that's then the Commission proposals, then the normal legislative process goes on with member states, with European councils, and so on and so forth. And in the last MFFs, typically this was concluded really at the very end of the current MFF, so of the current multi-annual financial framework. So this means in end of 2027. No? So everybody would be happy if this is maybe a bit earlier, but well. We have to take into account as well that the overall political situation is, of course, challenging for everyone at the level of member states, at the level of Commission, how to finance all these, or our response to all these challenges. So, yeah, that's maybe just to set a bit the scene. I think I could have some comments more on more detailed aspects here of what was presented, but I think that's not the time here to, or I don't want to monopolize kind of.
Maybe we can discuss it over lunch. I do have the microphone. Yeah. Are there other questions from the audience? Miko. I think you can keep the microphone.
Would have saved a few minutes maybe. What Hugo said is really important, and I would put a few small numbers to it. Satellites, we go from 7 to 19 in the next multi-annual financial framework. That's almost tripling, and it's Copernicus free. So I think one of the simple things would be it is very well based to triple the budget of the Copernicus program. That might be a little overshooting, and then at least double. So I think these are the numbers that is good to talk with, because it's not that a little bit or inflation plus a little.
And am I right in thinking you are speaking in official capacity for your government?
Yeah, no, but I'm doing this in Finland already. So for Finland, I have already I talked with the ministries that are in this frame, that please be aware that this thing is going to grow bigger than you might expect, but it's well-based, and it's anyway, Copernicus program is the only really good thing where European Union reaches lots of people everywhere, and I think the Copernicus Climate Change Service is especially good at this. So that's why it shouldn't be difficult to sell, but it is still something that we need to work for. But thank you very much for all that good stuff.
Thank you. There's a question here in the front from Sandra.
Sorry. On the budget, who are the users of all the Copernicus services, and is it only a European issue, or can it become larger in collecting fundings for a service? No.
Yeah. Well, I can respond for C3S with a good strong number, and I don't know if I don't have the statistic for Copernicus as a whole. For C3S, the user we monitor are more than around 50% coming from Europe, and the other 50% is spread between Asia, North America, South America, and Africa and Australia. In terms of profile of users, there is a mixture of academic, private sector, and government, and it's actually different from data set to data set. For instance, seasonal prediction has a very large fraction of private sector users, while other data sets are more academic based. So we have that understanding. We have an understanding of who the users are. It's also a European project, so the funding is 100% coming from the EU, and at the moment there is no plan to enlarge that in any direction. But if there is such a plan, Hugo will be able to comment later, but I'm not aware of any plan in that direction. Something that we want to do is to give a bit more visibility on who our users are, because it's an information that is actually useful to the community. Part of it is already available on the CDS, so if you go on CDS Live, actually you get the statistic, country by country, and some understanding of the different sectors. Yeah. Maciej.
Just to supplement also Hugo's comment on the future plans for the Copernicus International. I'm also representing parts of Organization for Bilateral Climate Cooperation of EU with in particular Global South, and I really praise also the national initiatives like the Danish with the South or the Portuguese. We are really very happy to hear that. We are also supporting Copernicus, like promoting them in the bilateral cooperation agreements. but we are not expecting just to have it just one way. We are also expecting to have cooperation with the getting in situ data that are important for overall projections. So we are also thinking about that with the different effects, of course. And last but not least, the Copernicus hubs, international hubs, two in Panama and in Philippines. They are there to stay. And partly they are financed not only from the space program, but from the international cooperation funding, which is the same process for the agreement for the next MFF, like Hugo mentioned. So.
Excellent. Thank you very much for this addition, Mathieu. I'm sure there are other questions. Maybe we can take those later, or even after the GA via email or in a dedicated discussion. Because I think we are sort of getting towards the end, and there are a few things I want to do before concluding, starting with a regular element of our exercise, which is the awarding of the prize for the best poster. So for that, I would like to invite Joaquin Munoz, who will tell us who has been the selected best poster for the first round of poster and the second one. I think there is a microphone there.
So there are two prizes, two wonderful prizes that we're going to award for the best poster of 2025 GA. So after careful evaluation of all our criteria, the jury have, by unanimity, decided that the best poster of the 2025 GA award is, what is it? Yeah, there are two slots, okay? This is for the first slot, Monday morning and Tuesday morning, right? Is that one?
Yeah.
Yeah. So the best poster for that one goes to Ricardo Deus for enhancing climate monitoring in Portugal. Won the whole prize. You can open it because there are more goodies inside.
Exactly what I wanted.
Okay, another shirt. And now,
that's box. Good.
Thank you.
Thanks to you. And the second winner of the second slot goes to Tim Hempel. Sorry for the pronunciation. Well done.
Thank you.
Well done.
Picture. Is it different?
I think it's the same.
Thank you very much.
Well done to the winners. Well done.
Thank you, Joaquin. Well, first of all, now we are really wrapping up. No, you don't have to stand me for much longer. First of all, I would like to thank you all. Thank you for coming here to Valencia at this 8th General Assembly. I really hope it was as interesting and informative for you as it was for me. I really enjoy my time here, and I listened and I learned a lot from what you said. I was aware of most of it, but even myself at times I missed things happening in the program, so it was really useful. We have now reached the end, which also means we won't have any more food and drinks to us to enjoy here in these beautiful terraces. But before we part, I would like to thank all the people who made this event possible, starting from Delphine, Joaquin, with whom I designed the program for this day. So thank you. Also, Elizabeth, who helped with her team, and the interaction with the facilitator and institution. So thank you for all the comms team. Thank you. I would like to thank all the conveners and the different sessions, and really they made the different sessions fly. I would like to thank Adria Congrex, who made actually this event possible, and the logistics, the logos, and all the materials. So thank you, thank you. Well, I'm sure you have realized that I haven't I'm sure you've noticed that I purposely left out the key person behind this event, and as a matter of fact, the key person behind all C3S GA over the years. And I left for her the best spot at the end of my thanks. So I would like really to thank Francesca Fusco, with whom this GA would have been totally impossible. So now I'm left with one remaining task, and is to tell you, oh, no, two remaining tasks. There you are. One is this beautiful, beautiful snapshot, visual snapshot of what has happened in this GA. This was made during the GA, reflecting on our collective discussion. So in the past, I actually used to lead a European project. There was a project called Euporius I led in the past, where we took visual notes of the meeting, and they stay with us forever. I still use those notes. So this was done by Georgia, and it was an excellent, in my mind, an excellent summary of our discussion. We will expand and build on this. So well done, and thank you for this input. Now I'm really left with only one remaining task, which is to tell you the location and date of the next GA. I know this is not me. I normally don't know what I'm doing the next day, but this job changed you, so I'm getting more and more organized. So the location and the date of the next GA is Budapest. We will be in Budapest from the 1st to the 4th of June next year. So with that, I wish you all a safe journey back home, or a nice stay here in Valencia if you stay, and see you in person, if not any sooner, next year in Budapest. Thank you very much.